Hello everybody, I'm Babak Saremi, market researcher and data analyst. Today I'm going to talk about parametric hypothesis testing using IBM SPSS and Microsoft Excel. In another video, I will cover non-parametric and attribute hypothesis testing. Just note that the level of the contents is intermediate, so if you are not familiar with basic terms of statistics like histogram, p-value, or normal distribution, I suggest you to start with basic trainings first. There are some good sources and videos on YouTube for free, for sure. And also you can go to lynda.com, which is a very good source for basic trainings of the statistics. In a nutshell, there are some differences between parametric and non-parametric tests. Parametric tests assume underlying statistical distribution in the data is normal. So several conditions of validity must be met so that the result of a parametric test is reliable. For example, t-test for two independent samples is reliable only if each sample follows a normal distribution and if sample variances are homogeneous. So parametric data are normal and continuous. Also, the tests consider means while non-parametric one consider medians. Non-parametric tests don't rely on any distribution, so they can be applied even if parametric conditions of validity are not met. And data in non-parametric tests are discrete. Parametric tests often have non-parametric equivalents, and I will talk about it in depth later. For testing normality and homogeneity of data, you can watch my first video on cleaning and preparing data. Here is an overview of parametric hypothesis tests. So first you have to check your data for normality, and if your data are normal and you're going to compare the means, you can easily use one sample t-test. And if you are going to compare the variances, just choose a one sample variance. And if you have two or more samples, then first you have to test your data to check the equality of variances and whether the variances are equal or not. Easily for two samples, choose two sample t-test for comparing means and one-way ANOVA for comparing the variances. Null hypothesis will be rejected if p-value is lower than 0.05, and for testing means, null hypothesis assumes equal means, but for testing variances, null hypothesis assumes equal variances. So your decision criteria are based on the number of samples that you have, whether there is one sample or there are two or more samples, and the criterion that you are going to focus to compare, which could be mean or variance. If the comparison base is mean and you have just one sample set, in SPSS you can easily run one sample t-test for running t-test and z-test syntax for running z-test, because we don't have any z-test menu or option in SPSS. So we have to use syntax, which is the SPSS language. And here in this case, null hypothesis is mu equals to m, in which mu is the mean of the sample and m is a specified value for mean. And alternative hypothesis could be one of these three forms. The first one, mu is unequal to m, which is a two-tailed test. And for the second and the third one, mu is smaller or greater than m, which are one-tailed tests. Here in this picture, you can see the differences between two-tailed and one-tailed tests. So in two-tailed tests, we have two critical values, but in one-tailed tests, we have just one critical value. If we have two sample sets, then we can easily run two sample t-tests, and the null hypothesis there is mu1 equals to mu2, and the alternative hypothesis could be mu1 is unequal to mu2, which is a two-tailed test, and mu1 is smaller or greater than mu2, which are one-tailed tests. If you have two or more samples and you're gonna compare the means, you can use one-way ANOVA, and you test the equality of means of all samples that you have. It could be, for example, two set of samples, 3, 4, or more. Here I have focused on 3 sample sizes. So for example, it's mu1 equals to mu2 equals to mu3. And the alternative hypothesis, which causes the rejection of null hypothesis, is when at least one mean is different. So even if one of these means is different from the others, then the null hypothesis will be rejected. And we don't have, any discussion on tails here. And we also have another test in SPSS, which is paired sample t-test, which tests a phenomena before and after, for example, implementing a technique or changing something in it. So this is the paired sample t-test, and in this technique, the null hypothesis assumes that the means of the samples taken from before and after running the technique or doing the changes are not different. So it is MD equals to 0, and the alternative hypothesis could be MD is unequal to 0, which means that the means are different, and this is a two-tailed test, and or MD could be smaller or greater than 0, which both of them mean, again, that means are different and they are one-tailed tests. So let's go to SPSS and Microsoft Excel to run these tests. Okay, to run the tests for comparing means in SPSS, you easily go to Analyze and Compare Means. And here, if you have one sample and you want to compare the mean of that one sample with the specified value, you can run this test, one sample t-test. So I'm gonna check the X6, which is the product quality, and it is, as you can see from here, it is a score between 0 to 10. So 0 is a very poor quality and 10 is a very good quality. So I'm gonna test this one, and the specified value will get entered here. So I will check if the mean is equal to 8, for example. And here I can check the confidence level. Here it is 95%, so I'll leave it unchanged now. And then, okay. Okay. This one is the result. So we have one sample statistic, number of cases, which is 100, mean of the cases, which is 7.8, standard deviation and standard error. Here in the second table, we have one sample test, the t-test, degree of freedom, and this is the significance level, which is 0.177, and it is greater than 0.05, and this means that the null hypothesis is accepted. So uh, based on this confidence level, which is 95%, we can say that the means are equal. So the mean of the sample is equal to the value of 8. And they're very close, you can see. It's 7.8 and it's 8. Let me close this one. And then if we have two samples and we want to compare the mean of those two samples, just go to independent sample t-test. And here, again, I choose X6 and choose the region for grouping variable because I have two groups here. One is inside North America and one is outside North America. So I just enter 0 and 1 for group 1 and group 2, continue, and this one is again 95% of confidence level, and okay. The first table is the group statistics inside North America and outside North America. Number of cases for each, means, standard deviation, and standard mean, standard error mean. This table is more important. It's independent sample test. And you can see the Levene's test for equality of variances here, which is not significant. Actually, it's for F test. So it's 0.000, and the T degree of freedom and significance level for t-test for equality of means. These ones are more important here, and you can see that the confidence level is still 95%. So it is 0.000 for both equal variance assumed and equal variances not assumed. And because this is lower than 0.05, we reject the null hypothesis. So the null hypothesis assumed that the means are equal. So we reject it and accept the alternative hypothesis, which means that the means are different from each other. And you can see from here that the means are 7.2 and 8.7, which are far from each other. And another test here is the one-way ANOVA. For more than two samples, two or more than two samples, like 3 samples, 4 samples, etc. So again, I choose X6, and instead of X4, I choose customer type, because for X1, you can see that we have 3 types of customers, 1, 2, 3, here under X1. And then I go to options and choose homogeneity variance test, which runs the Levene's test. So, okay, yeah. The first table is for the Levene's test, and you can see the significance level. And this one, which is more important, is ANOVA test. And you can see that the significance level is 0.000. Also here, based on mean, the Levene's test is 0.000. And this means that the null hypothesis is rejected, which means that means are different from each other. And here, from the plots, you can see that the means for the mean for customer with over than 5 years is significantly different from other customers. For example, customers with less than 1 year and customers with 1 to 5 years. And this one shows that we reject the null hypothesis and keep the alternative hypothesis. And the last one, the last test, is the paired sample t-test. So I go to Analyze, Compare Means, and then, paired sample t-test. But let me do it with another data set that I have. So I have 20 cases. There are 20 customers, and they gave me some scores before changing, a kind of advertisement. And then after changing the advertisement, they gave me new scores. So I want to check if changing the advertisement has affected the customers in a positive way. So you can see the before scores here. For example, for the case number 1, he or she gave me an 18. And then after changing the advertisement, he or she gave me a 22. So I'm going to test if the means for before scores and after scores are the same or different. So just go to Analyze, Compare Means, and Paired Sample t-test. I can add more than one pair, but here I just have one pair. So just drag before scores here and after scores here. And again, it is 95% of confidence level. So, okay, here is the result. It includes 3 tables. First one is paired sample statistics, including mean of the before scores and after scores, number of cases, standard deviation, standard error mean. And the second table is the paired samples correlations with the significance level of 0.000. And the last table, which is the most important one, is the paired sample test for the paired differences. And you can see the mean, standard deviation, standard error mean, and 95% of confidence level interval of the differences, T statistic, and degree of freedom. And the most important part is the significance level, which is 0.004. That is lower than 0.05. And this means that H0 or null hypothesis is rejected, and the alternative hypothesis is accepted. And this means that there is a difference between means of the groups, which the first one you can see that is 18.4 and the second one is 20.45, and it is based on the 95% of confidence level. Okay, if you look for z-tests in the Analyze and Compare Means, you cannot find, any drop-down menu or option for doing the z-test in SPSS. And this is because in the real world, the t-tests are used more. And another reason is that z-tests are for the sample size is greater than 30, and t-tests are for sample sizes, less than 30. But when you have a greater sample size, like 100 or 200 and more than that, then the results of t-tests and z-tests are the same. So this is why they didn't put, any option for z-tests in the SPSS. But for doing z-tests, you can use the Microsoft Excel. Here is a data set that I have. There's some scores with the assumed standard deviation of 5. And the null hypothesis assumes that mean equals to 23, and the alternative hypothesis assumes that mean is unequal to 23. So for running the t-tests and z-tests in SPSS, just make sure that in data tab you have data analysis option here. If you don't have it, just go to File, Options, and Add-ins, and make sure that Analysis Toolpack is active here. If it is inactive, or it is under the inactive application add-ins here, just click on Go and check the Analysis Toolpack and OK. But now I have it. So here you can see that from this list we have some analysis tests in Microsoft Excel. For example, we have t-tests for two sample assuming equal variances or unequal variances, and also we have t-tests for paired two sample of means. You can also run the tests here, and it's very easy. Also, we have a z-test here for two samples, but here, because I'm gonna run the z-test only for one sample, so let me go first here. I add a dummy variable with the value of 0 here, and then go to data analysis and two sample z-test. Again, consider that I'm not gonna run two sample z-test. I'm gonna run one sample z-test. So if you had, two columns of data, which were representatives of two samples of the population, then you could, for example, select the first column as the variable for the first range, and variable 1 range, and for the variable 2 range, you could select the second column. So let me choose this one for the first one, and you can see that, yeah, we have 35 because we had a title for this, a label for this column. So there are 35 cases. And for variable range 2, I easily choose dummy and the number 0. So here I'm gonna to test the hypothesized mean difference. So I enter 23, and for the variance of the first variable, because the assumed standard deviation was 5, so I will actually put 25, which is the squared number of 5 here, and Because Excel doesn't accept 0 here, I just put a very small number, very close to 0. And because I have labels here, I just check labels. And this one shows that the confidence level is 0.05. And I can have the output here or in a new worksheet or a new workbook. So just OK. I don't want this column, so I will delete that one. And now you can see that we have mean. And let's change this one. This is one sample test, not two samples. And we have the mean, which is 21, and variance, observation, hypothesized mean difference, which was 23. And these values are very important. Z p-value for one tail, Z critical for one tail, p-value for two tail, and Z critical for two tail. And if you remember, our test was, let me check. Oh, this is the sheet one. Yeah. This is a kind of two-tailed test. So what is important for us is this P and this Z, which are for two-tailed test. And you can see that the Z value here is minus 1.25. So because minus 1.25 is not in the critical area, and actually it's lower than the absolute amount of 1.95, and also as the p-value is greater than 0.05, then you don't reject the null hypothesis. This is actually different with describing and explaining the significance level in the t-test. So we accept null hypothesis, and null hypothesis was mu equals to 23. You can also do other tests, as I mentioned before, like two sample assuming unequal variances, equal variances, and paired two sample for means. And I'm not gonna run these tests, but just show you that they're not that complicated. So for example, if you are gonna run the paired sample t-test, then you have two ranges of variables, and if you have labels, just check this one. You can change the alpha to, for example, 0.01 for 99% of confidence level, and just OK. And other tests, this one again is the same, and this one is again the same. So they're not that hard. You just practice. Okay, if the comparison base is variance and you have just one sample and your goal is to compare the variance of that sample to a target, we don't have any test or drop-down menu in SPSS or Microsoft Excel, but you can use some add-ins like Excel Stat and SPC, and maybe other software like Minitab. I will talk about one of the add-ins later. And the null hypothesis in this case assumes that the variance of that sample equals to the specified variance value. And the alternative hypothesis could be variance is unequal to this unspecified value, which is a two-tailed test, or variance of the sample is smaller or greater than the specified value, which are a one-tailed tests. If you have two samples and you are going to compare the variances of the samples, you can run Levene's test in one-way ANOVA. Again, it hypothesizes that the variance of the first sample is equal to the variance of the second sample, and the alternative hypothesis assumes that the variances are not equal, which is a two-tailed test, or variance of the first sample could be smaller or greater than variance of the second sample as the one-tailed tests. And if you have three or more samples, you can run a Levene's test again in one-way ANOVA, or Bartlett's test in MANOVA or factor analysis. I will talk about them in detail in my videos on multivariate data analysis. And this case assumes as the null hypothesis that the variances of all samples are equal, and if at least one of the variances is different from the others, then the null hypothesis will get rejected. And this one doesn't have anything to do with the number of tails. And we also have another test named repeated measures ANOVA, which is equivalent to a paired sample t-test. And but in that case, we compared the means. Here we compared the variances, and as the null hypothesis, it assumes that the variance difference equals to 0. And if we focus on the inequality of the variance to 0, it could be a two-tailed alternative hypothesis. And we also can focus on the variance to be smaller or greater than 0 as a one-tailed test. Okay, as I mentioned before, there is no any option or drop-down menu in Microsoft Excel or IBM SPSS to run the one variance test. And this is because the test is not frequently used. But you can, for example, use SPC for Excel, which I have downloaded, and it's now added to my drop-down menus. And other software like Minitab or maybe Excelistat or some other add-ins. Now, this one is a data set that I have, and I got it from SPC. Let me go to SPC website. Yeah, this is the SPC Excel. You can see the address there. And for sure, you can download a demo for, and this one is 20-day free demo. So easily you can use this one and buy it later. And let me go to Microsoft Excel. After you download and install the demo, just make sure that your Excel is closed before running the SPC setup option. And after it is downloaded and installed, then one menu will be added to your Microsoft Excel named SPC for Excel. And you can see that there are many techniques and things that you can use in your data analysis. So for this one, I also got the uh, database from their website, so I'm just going to run the test with their uh, data set. Uh, they have something here named density, and I'm gonna test the variance test for uh, just this one sample. Easily, I select everything here, including the heading. So make sure that you choose the heading also. And then go to sample tests here in the statistical tools. And then you can see that there are some techniques and some methods that you can use for data analysis, like one sample Z and t-test for a mean that we didn't have in the SPSS, one sample variance test that I'm going to run, Z and t-test for differences in two means, t-test for paired sample comparison, one proportion test. These are, these two are some non-parametric tests, and they are related to the attribute hypothesis testing. So I'm going to talk about them later. And power and sample size. I'm now going to choose one sample variance test. Okay. And you can see that the data range that you selected uh, is brought here. And now I'm choosing include hypothesis test. Just note that you have to enter the hypothesized standard deviation, not hypothesized variance. So I am going to enter 0.23, and here you can choose your data hypothesis type. You can choose two-sided or one-sided, or change the alpha. I just leave them unchanged now. And now here from output options, you can choose where you want your output. Do you want it in a new worksheet, or for example, you want it here? I'm going to choose the output here. Okay. And also you can enter sigma and sample size. We are not going to do that. And easily just OK. Now you have output here. The confidence level is 95%, and you can see the null hypothesis and the alternative hypothesis. And this shows that it's a kind of two-tailed test. These are some information: standard deviation, variance, sample size, degree of freedom, alpha, LCL, UCL, and things that we rarely use in SPSS. And but the most important part is this one, the p-value, which is really great, 0.9279, and the result is here. The null hypothesis is accepted. If the p-value is lower than 0.05, then you have to reject the null hypothesis. But you can see that it's very big. It's almost 1. So there is no evidence that variance doesn't equal 0.0529. 0.0529 is the specified value for the variance. If you remember, we entered standard deviation, which was 0.230, and the variance is the squared amount of the standard deviation. And you also can see that we have got some plots. And this one shows the variance, hypothesis variance, LCL, UCL, and we also have density data plot, which is used in the production process. To compare the variances of 2, 3, or more groups in SPSS, easily go to Analyze, Compare Means, and One-Way ANOVA. And here I choose X6 or product quality as a dependent variable and region as a factor. And this is because region has two groups inside and outside the United States. I then go to options and make sure that I choose homogeneity variance test, which is the Levene's test. And I don't choose means plot because this is for comparing means. I also don't need to choose homogeneity of variance test in comparing means, but I did that to show you the results. And just continue. Okay. And now we have two tables, test of homogeneity of variances with the significance values lower than 0.05 and the ANOVA test or F test with the significance value of 0.000. And this means that the null hypothesis is rejected and alternative hypothesis is accepted. And again, it means that the variances of these two groups inside and outside the United States are not equal. So now I run the test again. Now for three groups, I just changed the region with customer type. If you remember, we had three types of customers. So now just make sure that you have chosen the homogeneity of variance test. Continue, okay. And now we have two more tables. Test of homogeneity of variances and ANOVA. All of the significance levels are lower than 0.05, which means that the null hypothesis is rejected and at least one variance is different from the other variances for the three groups of customers. To test the paired sample variances, I postponed the discussion on repeated measure ANOVA to multivariate data analysis, but I'm gonna show you a very easy way to run the paired sample test using Microsoft Excel and also a test named Pitman-Morgan. You can find this worksheet in this website, howtostats.net, and go to that website and just search testing difference between correlated variances. And there's a worksheet here on this page, and you just have to enter some data, a variance for group 1, variance for group 2. I mean for the pre-test and post-test, and then sample size and correlation. And it will give you the significance and t-value and other statistics. So I want variance number 1, variance number 2, sample size and correlation. So let me go here. Again, I have the data set for before scores and after scores. So let me calculate the variance for the first column and variance for the second column. So let's name it V before and V after. Okay, V variance for before test and variance for after test. And also I want the correlation. So just use the correl function, array 1 and comma array 2. And yeah, now I have the variance for before scores, variance for after scores, and the correlation between them. And also the number of samples is 20. So let me just copy and paste these values. This is variance number 1. This one is variance number 2. The sample size is 20 and the correlation, copy and paste. Okay, now you can see that we have two options, results for option 1 and for the two-tailed test. We have t-value, degree of freedom, and significance, which is 0.5588. That is greater than 0.05. So we accept the null hypothesis, and null hypothesis will not get rejected. So it means that variances of these two sets of scores are the same. Thank you for watching my video today. Don't miss the discussion on non-parametric and attribute hypothesis testing using SPSS and Microsoft Excel in the next video. Take care.